Welcome to Excel Business Statistical Analysis video number 24. Hey, in this video, we got to see how to use formulas to build discrete probability distributions to help make business decisions. Now, back in video number 6 in this class, we saw how to take Isaac's Italian Restaurant data and create a frequency and percent frequency distribution, and then a visualization. Then we saw how to take a data set from Dick's Hamburgers, build a frequency, percent frequency distribution, and chart. But in both cases, we used pivot tables and pivot charts to create our reports and visualizations. But in this video, we'll take the same data set, but we're going to use worksheet formulas to create the same report we did in video number 6, but now we'll call it a discrete probability distribution. Instead of calling it relative frequency, we'll call it probability. Then we'll create a bunch of other calculations like mean and standard deviation and calculate our probabilities. Now we're going to work on the sheet PD2. Now let's talk about worksheet formulas. Why would we use them instead of a pivot table? Well, worksheet formulas have two advantages over a pivot table. One is that the report can instantly update when source data changes. And in our data set, we're given 6 months of data, but we need a report now. Later, when we add more data, we'll just add it and everything will update. And the second thing is, when you use formulas to create your report, you can select part of the report or the whole report and make a chart. Now, back in video number 6, when we created frequency and percent frequency in a single report, when we made a chart, we had to have both calculations in the chart. And that required that when we wanted a frequency and percent frequency in two different charts, we had to build two different pivot tables. Here, we can pick and choose any columns we want. The column chart will not care. If we want both, no problem. If we want just one, it'll do it just fine. Here are the 6 steps to building a discrete probability distribution. Step number 1, we need to define a random variable. Now, the variable we're interested in for making business decisions is number of banquet rooms used. So we'll define our variable x equals a random discrete variable, number of rooms used for the day. Step 2, we need to build our frequency distribution. Now, in the first column of our report, we need every possible x value. And it's not just 1 to 4, because we can definitely have days where 0 rooms are used. So what we really need is 0 to 4. To generate the numbers 0 to 4 with a formula, we'll use the amazing sequence function. Now, it needs to know how many rows. We're going to have 4 rows, and we need 0, so +1, comma. We don't need any columns, comma, and our start value, 0. The step we don't need to put in because the default is 1, which is what we want. Close parentheses, and when I hit Enter, 0 to 4 spill down the column. Now, this is a spilled array formula, so all of the cells below the top cell are grayed out. Only the top cell has the formula. Now, when we want to count for each x random variable, we can do that with the COUNTIFS function. Criteria range. That's the entire rooms used column. And this is an Excel table, so I simply hover my cursor. And when I see the downward pointing arrow, I click. That puts in the table name, and in square brackets, the field name, comma. Our criteria, well, if I put a 0, COUNTIFS would give me the count for 0. But if I highlight the entire spilled array, Excel knows that this is a spilled array and that the formula only lives in D16. So it points to that cell and then uses the spilled range operator, which says, get everything that spills from D16. And that's our formula. Close parentheses and Enter. So there were 0 days when 0 rooms were used, 12 days when 1 room is used, and so on. Now we come to the bottom, and Alt equals. Notice that points to E16 because the formula spills from there. And when I hit enter, I get a count of 50. So far, we have 50 records in this data set. Now we need to calculate relative frequency or percent frequency, or in this chapter, the probability of X. So I need to compare each individual item to the total. So in the top cell equals, and here I'm going to use left arrow. I know the formula is spilling from there, so I can just type pound or hashtag. That's the spilled range operator. Now I'm going to divide all of those values by a single value, 50. When I hit enter, the probabilities for each X value spill down the column. Now what we did was step 3. Now we need to complete step 4. We need to check our requirements for a discrete probability distribution. Are each individual probability greater than 0? And we need to check if the sum is equal to 1. So requirement number 1, alt equals, and when I hit enter, I get 1. Now I'm going to do a spilled array and just check. So equals, every one of these I need to ask the question, are you greater than or equal to 0? When I hit enter, it'll spill trues down the column. Now before we even do step 5 and 6, we can make some conclusion or make some business decisions based on this discrete probability distribution. Clearly, people like the banquet rooms. Maybe we don't need 4 rooms. That 4th room didn't get used very often. Staffing should anticipate 1 to 3 rooms being used. And it looks like 2 rooms got a whopping 42%. Now, step number 5, we want to create a column chart. And anytime you create a frequency distribution or a probability distribution, it's helpful to visualize to see the patterns in the probabilities. And because we're using formulas, we're not forced to use all 3 columns. The only column I want in this table that will determine the column heights in the chart is this column. So I'm going to highlight not the total, just the label at the top and the values. Go up to Insert, Charts, drop down for Column Chart, and we're going to use the first one, Clustered Column. And there we have the probabilities plotted, and the height of each column represents the probability. Now let's point to the edge and move this. And we definitely want to replace the default values that were put in, because our x variable is not from 1 to 5. It's from 0 to 4. And those values come from these cells. So we need to remove the default labels and put these numbers in. To do that, we select the chart. And in Chart Design, you can click Select Data. Or in the chart, right-click, Select Data. Now, the Select Data Source dialog box is the real power to charting when you have formulas. Notice we're allowed for the series, those are the numbers, we're allowed to add a new series, edit this series, or remove. None of these are available when you use a pivot table. Also, we can edit the horizontal axis. So I want to click Edit. The dialog box is empty because it used default values. We simply highlight our x values. There they are. Click OK. Click OK. And now we have the correct x variable in our horizontal axis. Now we definitely need labels for the vertical, horizontal axes and our chart title. So we're going to come over to the green plus, click. I'll check Axis Titles. The vertical axis label is selected, and notice it has a solid line around it. That means we can link it to the cell. So I type in equal sign. That shoots me up to the formula bar. I'm going to click on the cell with P of X and Enter. Click on the horizontal axis, equal sign, and that's our x variable. When I hit Enter, there's a clear label to indicate what the x variable is. Now for the chart title, I'm going to click equal sign, and I already typed a chart title off to the side. When I hit Enter, well, that's a little bit too big. I'll go to Home, change the font maybe to 10. All right, so now we have a chart that shows us the pattern. And this will update when we add data later. So I'm going to move this down here. Next, we have step 6. We're we're going to make predictions, but before we get to that, we need to make a bunch of calculations and calculate expected value, which is our mean, and standard deviation. Now, here's the formulas for expected value. That's just a weighted average, our mean, variance, and standard deviation. And these formulas are used when you only have a discrete probability distribution with the x values and the probability. Now, the beautiful thing about this situation is we have both. We have the data set and the frequency distribution. So we'll use these formulas to calculate mean and standard deviation from our discrete probability distribution. And then we'll also make the calculations from the original data set to prove to ourselves that these formulas really work. Now, the first calculation is our expected value. And it's x times probability. Those are the x's. These are the probabilities. Anytime we're going to multiply two columns and then add, the perfect function is sum product. Array 1, it doesn't matter which one you put in first. I'm putting in x, comma, array 2, the probabilities. When I hit enter from the frequency distribution, now I've calculated the mean. The average number of rooms used per day, 2.18 rooms. Now let's calculate from the original data set, and we better get exactly the same answer. I'll select this column in the Excel table, and when I hit enter, there it is. I get the same answer. Now variance, we calculate that, and then to calculate standard deviation, we take the square root. Variance has a problem with units because we square it and we get squared units. Standard deviation, by taking the square root, will undo that. Now notice this is very similar to how we calculated standard deviation from the full data set back in Chapter 3. We take the x values, subtract the mean, square it, multiply it by the probabilities, add, and then square root. Now we're going to do it step by step in the cells. But eventually, once we do it once or twice and understand all the calculations, we really want to do it in a single cell formula. Now, the first calculation equals the full column of x values minus the expected value. When I hit enter, the values spill down the column. Now, this is a different calculation than when we calculated deviation back in Chapter 3 for standard deviation. Deviation uses every single number from the original data set. We're just using the x values. So unlike standard deviation in Chapter 3, if we add up these values, Alt equals, and then hit enter, we do not get 0. We're going to get some other number besides 0. And if you wanted to prove that to yourself, you're like, wait a second, that doesn't make sense. Well, these are not the full original set of data. Down here, we'll just calculate the sum of the deviations, which should be equal to 0. So sum, the full column, all the number of rooms used, minus the mean. And when I close parentheses and enter, oh yeah, that's exactly what we got back in Chapter 3 when we were doing a slightly different calculation. All right, so we have random variable minus the expected value. Now we need to square. So we highlight the full column, caret 2, and enter. Now we need to multiply these values times the probabilities. And we need them to spill, right? We need all the individual values. It doesn't matter in which order we multiply. There's the probability times this column of values. When I hit enter, that will spill. Now to get variance, we need to add. So Alt equals, it guesses wrong, so I redirect to get the correct values and enter. There's the variance. To get standard deviation from variance, we use the square root function. Square root of variance, when I hit enter, bam, there it is. Standard deviation, a measure of the spread in the data set, the dispersion. It tells us how well our mean represents all the data points in the original data set. Now, we definitely want to calculate a single cell formula, just like we had up here. And we can notice, well, we took x minus mean, and that gave us a column of values. But then we just took that column of values and squared. Then we just took that result, multiply it by another column, and then add and take the square root. So just as we did back in Chapter 3, we're going to do the entire formula in a single cell. And we'll actually do it step by step before we aggregate it with a sum and square root. Now, there's nothing below here, so temporarily, I'm going to do step by step, taking all of the x values, and I'm going to subtract the expected value. When I hit Enter, I see number formatting is showing me a bunch of decimals, but I get exactly the same number. F2, I need to put parentheses around subtraction, because I want to force that to happen before squaring it. Caret 2, Control Enter. I see the same values up here. F2. Now we multiply times the probabilities. When I hit Enter, this is the step before adding, and I see the same values over here. Now I'm going to very carefully type sum and open parentheses, and then close parentheses at the end. This should give me variance, and sure enough, it does. F2. Now I take the square root. And look at that little teeny formula. How much more compact. And really, in the long run, how much easier is it to do it this way than the step-by-step way. When I hit Enter, I'm hoping I get the same thing, and I do. Now, we want to check against the data set here. And because this frequency distribution was made from this data set, and this data set is all the values, the standard deviation built-in function that we use is the p version for population. But when I highlight the entire column and Enter, I get exactly the same thing. Now again, this calculation and this one right here, these are the calculations you make for mean and standard deviation when you're only given the probability distribution. If you have the data set, then obviously it's much easier to use the built-in functions. So we have an average of 2.18 rooms used per day. And the standard deviation for that average or that mean or expected value is 0.88 rooms. Now remember, with standard deviation, the smaller this is, the better this represents all the data points, and the more reliable it is to use for planning. The bigger it is, that means there's more spread in all the data points as compared to the mean. The bigger this is, the less reliable the mean is for planning and budgeting, but also as a single value that represents all the data points. Now we have our discrete probability distribution, our mean, our standard deviation, and we have our chart to visualize the distribution of probabilities across the random variable. Now we can calculate various probabilities. We want to know the probability that on any given random day, we use one or fewer rooms. Alt equals, I'm going to use the sum function and just come up and add 0 and 1. When I hit Enter, whoa, 24%. How about the probability of 2 or 3 rooms? Alt equals, there's 2 and 3, and Enter. So almost 70%. And if we want the probability that we're going to use a room at all, Alt equals, highlight everything except for that 0. And it looks like so far from the data we have, 100% of the time we're using at least one room. Now, we finished our probability model here, including probability distribution, a chart, mean, standard deviation, and a few calculations for probability. But this is an Excel table, and we used formulas. So if we start adding records to the bottom of this data set, which in fact, Isaac might be doing this, right? Every weekend, Saturday and Sunday, he adds 2 new records to the bottom. Well, all of this will automatically update when we add new data. Let's click in a single cell, Control down arrow, and I already added a bunch of new records here that we're going to add to the bottom of the table. Control asterisk to select all the new records, Control C. And this is an Excel table. If I paste something here, it will not be part of the table. But if I paste something right below, it will become part of the table object. And all of those formulas and charts are connected to this table object. So when I Control V, Control Home to jump to the top cell, look at that. Everything has updated. Our counts, our totals. It doesn't look like the mean changed, but the standard deviation did. Our probabilities did, and our chart updated. It looks like we have a few times in the end of the year where we had 0 rooms used. So we saw 2 advantages for formulas. If the source data is going to change regularly and you want your solution that you build to update instantly without having to refresh, then you use formulas. We also saw that it's easier to pick and choose from a report made with formulas when we're creating a chart. Now let's go over and look at our next example on PD3. Here we have a data set which represents the number of arrivals to Dick's Hamburger at 45th in Seattle at Saturday noon lunch during a 1-minute period. So here's a 1-minute period that was observed. 0 people came. Control down arrow, and they kept making observation, and the max number of people that arrived in 1 minute was 14. Control up arrow. So we need our x, 0 to 14, frequency, probability, and then mean and standard deviation. Now the first thing we can do is we can use the max function. And I'm going to look through this column, click in the top, Control Shift down arrow, Control backspace. And when I hit Enter, I get 14. Now 0 to 14 can be generated with sequence. How many rows do we need here? Well, 14 plus an extra 1 for 0, so we add 1, comma, comma. We're going to start the sequence at 0. We'll leave that empty because the default is increment by 1. So close parentheses, and I get 0 to 14 spilled. Now for each one of those x variables, we need to calculate the frequency. For that, we can use the COUNTIFS function. Criteria range, we need the whole column, Control Shift down arrow, Control backspace, comma, and the criteria, we put every single x value. And when I hit Enter, COUNTIFS delivers a count for each one of those x values. So look at that. 4 gets 266. 0 gets 28. 14 gets 1. Now we come down to the bottom, Alt equals, and so the number of observations, 1,305. For the probability, equal sign, left arrow, D15 is where the formula lives. So now I'm going to type pound hashtag the spilled range operator. Now we'll divide all the frequencies by the total at the bottom and Enter. There's our spilled columns of probabilities. Down at the bottom, we're going to check for requirement number 2. Alt equals, it better add up to 1, and sure enough, it does. Now requirement 1, equal sign, and I'll left arrow over. In E15, I know that's where the formula lives, so I type pound or hashtag. That gets the full spilled array. And then I'll ask the question, are you greater than or equal to 0? When I hit Enter, I hope I get trues all the way down. And sure enough, I do. Now that we've completed the probability distribution, here's some of the conclusions we can make. It looks like, if we add these together, 40% of the time, 3 to 4 people show up. And if we add all of these, 3 to 5, that represents about 50% of the time. And look at this. 2% of the time, nobody shows up for a given minute period during lunch hour. Now, let's create a column chart. I'm going to highlight all the probabilities without the 100% and the label at the top. Insert, column chart, right-click, select data, edit, and for the horizontal axis, we'll put in 0 to 14. Click OK, click OK. And we'll use the green plus because we want axis titles. For the vertical, equal sign P of X, Enter. For the horizontal, equal sign, and it looks like I have the X variable in B10 and Enter. if we move this, the chart title equals sign J12 and enter. We'll change the size to 10. And there's the shape of the probability distribution. And as we'll learn a few videos ahead, this shape is typical for something called a Poisson distribution. And we'll learn about that soon enough. Now we need to calculate our mean and standard deviation from our probability distribution. Equals sum product. There's the x values, comma, there's the probabilities. And when I hit enter, it looks like the average number of people showing up for a 1 minute period is 3.87. Now the standard deviation, you just take the x values, subtract the mean, and I'm going to square this right off the bat. So caret 2, and then I'm going to multiply it times the probabilities. That gives me that part times the probability. Now I need to add it, sum, and that would give me the variance. And we want to notice something here that'll help us a few videos ahead. The mean and the variance are almost equal. When that's the case, and you see a distribution like this, that's how you'll know that this is a Poisson distribution. And once you know that, as we'll see later, there are other ways to calculate the probabilities. But we want to convert this to standard deviation. So square root, close parentheses, and when I hit enter, so we have an average number of people showing up for a 1 minute period of 3.8 with a standard deviation of almost 2 people. So there's quite a lot of variation in this data set as compared to the mean. All right, now let's calculate some probabilities. What's the probability that 2 or fewer people will show up? Alt equals, there's 0, 1, and 2. When I hit enter, about 24%. How about the probability of 3 or 4 or 5 people showing up during a minute period? Alt equals, and highlight probabilities for 3, 4, 5 x variables, and enter. Wow, so about 56% of the time. Now let's calculate the probability that someone shows up. And instead of, like our first example, adding up all of the probabilities that are not for 0, let's just use the complement rule. Equals 1 minus. Remember, the 1 represents all of it. And there's just one item that's not in what we're interested in, so I subtract it. And there it is, 97.8% of the time, someone shows up. All right, in this video, we saw 2 examples of going from a data set using formulas to calculate a discrete probability distribution. We saw how to calculate the mean and the standard deviation directly from that probability distribution. We saw how to use a column chart to plot the distribution. And we calculated various probabilities and made various conclusions to help make business decisions. Now, next video, we'll have one more example of creating a discrete probability distribution. But we'll use Power Query to import data not from a CSV file, but from another Excel file. All right, we'll see you next video.